Okay guys, I hope you are watching because this is very important video. I will explain to you section 6.3 how to do truth tables. Now first of all, remember what we did last time. We were calculating the value, the truth value for a compound proposition based on the truth values which were given to us. We were told something like A, B, and C are true, and D, E, and F are false. Now, is it possible now to calculate all the truth values for a proposition? And the answer is yes, you actually can do that. Suppose you are given something like this. This is an example from the book. Now, how would you go about calculating all the possible truth values here? How big is it going to get? Well, not really that big. And this is how you do it. Now, first of all, you have to figure out how many components do you have. Well, in this case, just two, right? You only have two components, A and B. There is another B, but B and B are the same. It's the same component. So there is just two components, A and B. Okay, so let's put them here, A and B. Now, the next question you should ask yourself is, how many lines should you have? And the answer is actually for the simple mathematical formula. And the formula is, we will need 2 to the power of n lines. N being your number of components. So you have two components. Therefore, in this case, you need 2 to the power of 2 lines, which is 4 lines, right? Okay. How do you fill them? So this would be your 4 lines, right? 1, 2, 3, and 4. You don't necessarily have to put numbers there, but I'm just numbering them for illustration purposes. 4 lines, because you have 2 components, and so formula tells you you need 4. Okay. The first line here, half of it should be true and half false. What's half of 4? 2. So you need 2 true and 2 false. Next line, you divide it by 2 again. So here you had 2. What will be here? Well, just one of each. But you have to keep on repeating them, right? True, false, true, false. Your last line should always come up like this. We're really not going to go beyond 4 components, but theoretically you could have as many components as you want. The principle will always be the same. First, on the left you put half of them true, half of them false. Next line, half of that, and next line, half of that, until you reach the line with true, false, true, false, true, false, so just 1. Okay, so what do you do next? You always do negations next, because negation is the easiest one. Now you have a negation here, right, not B. So what you actually do is you take the B column, and because it's a negation, you put here the opposite of that, right? Negation actually flips it over. So instead of true, you will get what? False. And instead of false, you will get what? True. And instead of true, you would get what? False. And the same thing here. There you go. You've done your negation. Next, you need to do what is in your parentheses. A or not B. Now, since it is A or not B, we're applying for a rule for disjunction. What is the rule for disjunction? You should remember by now. This is important. The rule for disjunction is it's only false if both of them are false. In all other cases, it is true. Now, we have this column for A. This is the column. And we have this column for not B. And we are applying the rule here. Let's make sure you understand. So this is your A column, and this is your not B column, And because it is a disjunction, what you do is you apply the rule to these pairs, and you're looking for the one which is both false, because that's the only one which will be false. Do you have that? Oh yeah, look, both false. So that would be a false. What about the rest of them? They're true, because remember, it's only false when both of them are false. You will have true here, and true here. Okay, that actually is your value for this entire thing in parentheses. But you still have this, right? That means that you should do one more operation from that column here and B column. This is your B column, so you can copy it there if you want. The book does not do that, but let's do that. Let's copy it there. I will also do it in red, because this is our disjunction column in parentheses. I'll do this one in red as well. I'll just copy it, right? T, F, T, and F. Okay, so now we have this column, and we perform this operation. This is implication. What's the rule for implication? Again, you should know it by now. Implication, only if you go from true to false, it will be false. In all other cases, it will be true. So just look here, 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 and here. Do you have any situation when you go from true to false? Oh yes, look. This is one, true, false, so that will be false. And this is one, true, false, so that would be false. What's the other two then? They are true. And that now is your final result. True, false, true, false. This is how it's done. Okay, now let's do another example. And this is actually example 2 in the book. Normally, I would let you guys do it in class yourself, but we'll do it together. So, again, let's do the truth table for this proposition. Now, let's first of all figure out how many lines do we need. How many components do we have? Oh, look, again, 2. Just 2 of them. Both of them are there twice, but it is still 2 components. We have G and we have H. So how many lines do we need? 4 lines. Again, 2 of them. True, false, false. True, false, true, false. Same thing as the last time. Okay, now what do we do next? Well, we have brackets and we have parentheses. We do not have any negations. So we can do what is in parentheses first. We are going from G to H, and this is implication. Again, what's the rule for implication? Do you remember? From true to false, false. All others are true. Now this is actually fairly easy. We have it, all our values right here. So we just look in which ones is from true to false. Well, look, this one is. Anything else? No. So this one will be false, and the rest of them will be true. Okay, so we got what's in here, but we now have to do the whole thing in brackets. So we still have to do this operation. This is conjunction with G. This is our G column. This is this column. Let me mark them for you so that you would see. So G is actually this column here. And that whole thing is this column here. So we're comparing these 2 columns, and what we are looking for is the rule for conjunction, which is what? It's only true when both of them are true. In all other cases, it is false. So, true and true, true. True and false, false. False and true, false. False and true, false. So this is the result for the entire thing in the parentheses. Now we have to do the last operation here. This is actually implication. From this column, now this is our column. we just got it. This is the entire thing in brackets. To h, this is our h. So we kind of going backwards, right? Because, well, if we copy this column here, we'd be going in this direction. Well, let's copy it, just to make it easy for you. This is the column, right? T, F, T, F. Okay, now we're going in this direction, and we're looking from true to false, right? Is this from true to false? No. Is this? No. Is this? No. And this? No. None of them. Okay, so we don't have any from true to false. And remember, the rule is from true to false, false. In all other cases, it is true. So our final result here would be true, 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 and true. All of them are true. Now, what exactly does it mean? This is what we know in logic as tautology. Tautology is a proposition which is always true. Now, what would be an example of tautology in real life? An example of tautology in real life would be it is raining or it is not raining. Know that it's always true, isn't it? It is either raining or it's not raining. Sometimes students say, what if it's snowing? Well, if it's snowing, it's not raining, is it? So that still is true. This proposition is literally always true. Now, sometimes you can have a different result, which is also something you should know. And this is if all of them are false. So instead of true, 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 you have false, 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 false. False every single time. Now that would be what is known as a contradiction. A contradiction is always false. What would be an example of a contradiction? An example of a contradiction would be it's raining and it's not raining. Can you see the contradiction there? How can it be? But it is raining and it's not raining, right? So this is exactly what it is sounds like. It's always false. It cannot possibly be true just because it is a contradiction. Okay, now another thing, another possibility is if it's neither tautology nor contradiction, say some of them are true and some of them are false, something like that, for example, then that would be a contingent statement. So you can have tautology, which is always true, contradiction, which is always false, or contingent statement, which is all other situations. Now, suppose we are comparing two statements, and we are doing truth tables for both. Now, let's do one more example from the book. Okay, so this is the example from the book. This is one proposition, this is another one. Let's do truth tables for both of them, real quickly. Okay. How many components do we have? Just two components in each time, right? Here we have L and K, and here we also have K and L. Okay, that makes it fairly easy. So, we do the table. Now note that here we don't even have to do the table, right? It's the same two components. Let's just erase them because we don't need them. We can use this table. That is exactly the same K and L. Okay, so let's do the table. Let's calculate the values. We're going from K to L, so what situation would we have falsity when we're going from true to false? This is 1, and that's it. All the rest of them will be true. Now how about here? Well, here we have two negations, so we actually have to use the negation. We have to reverse them. Instead of K, not K would be the opposite of that, right? So not K would be false, false, true, true, and not L would be the opposite of that. So it would be false, true, false, true. Again, we have an implication, so the rule is every time we go from true to false, it will be false. Now here, for example. And that's it, right? Okay, so our final result here and our final result here. Do you see anything interesting about them? Look, they're exactly the same. Now that means that these two statements are equivalent. Equivalent statements are statements which have truth and exactly the same position. Note that we, in this case, when we're comparing them, we only care about truth. We don't really compare if they have falsity in exactly the same position. Although obviously if they have truth in exact same position, they will also have falsity. Now, the other situation could be a contradiction. If you do two statements and they do not have truth in the same position at all, like for example, this one has true here, this would have false here, this one has true here, this would have false here, and this one would have false, for example, here. Right? Note that they both have false in the same position, but it doesn't matter as long as the truth is always different. So this one true, this one false, this one false, this one true, this one false, this one true. If we got this result, and the book does have an example for that, now that would be a contradiction. Now, what other situations can we possibly have? What other situations we can possibly have? Consistent and inconsistent. Now, two statements would be consistent if they have truth in at least one position. So, for example, if this one have true here and this one true here, now then they are consistent. Note that if they are equivalent, they obviously are consistent. But sometimes they don't have to be equivalent, so they don't have truth in exactly the same position all the time, but at least once. Inconsistent, on the other hand, is if they don't have that. They never have truth in exactly the same position. Okay, that pretty much sums up truth tables. Hopefully that was enough. Please do the exercises, and if you have any questions, please ask me. There's a good summary of all that, and obviously take a look at the notes, but this is basically how you do it.